Hey everybody, welcome back to the channel. It's been a while since I've looked at the Tronxy X3 and I thought it was overdue for a little bit of attention. There was something that I wanted to do to this printer for quite a while now, and that was make it multifunctional and allow for quick change tooling. So I spent some time designing some components that would allow me to make it so that I could quick change tooling on the hot end here, and I also wanted to incorporate laser engraving into this printer. So we have 3 different sets of tooling that I came up with that allow us multiple functionality. So for a little further ahead in the video, you'll see how I install this back plate, an M3, a 10mm long M3 here. I'll just put it in my tooling assembly here. Hook that in place. Snaps down, and then we just tighten down our screw. And then that's firmly seated in place. Then all we have to do is, so we have a description printed right into this housing here that should line up with the printing that's in each assembly piece right here, so that there is no confusion. So we can just take that, snap it into place. All we have to do now is put our Bowden tube in, and we're good to go. If I want to switch, say I have another piece of tooling here that has a 5mm nozzle on it, or a 6mm nozzle, or even a 1mm nozzle on it, instead of like trying to heat the printer up so that I can get the filament back out, I can just pop this one screw and put another tooling on into place, line it up, and there we go. And again, we just put our wiring in such, make sure it's down seated all the way, and our Bowden tube, and there we go. If I wanted to do some laser engraving, again, it's just as simple as removing this one screw, unclamping that, moving the Bowden tube, taking this one screw out, my laser assembly here. In the back, here's where our screw goes. Make sure it's seated properly. Put your screw in. And then what we want to do here is we want our filament cooling. So it's our last one near the end here, unless you have a connector installed on here for your auto bed leveling, and I do have a space for auto bed leveling on all of these, as you can see here, but I don't use auto bed leveling, so that will remain empty for me. So we will connect our this in such a way that the filament cooling fan is powering the laser. We don't need the Bowden tube for this, right? So I could probably get rid of these being connected together here. And now I got my laser. And further along in the video, I'll go over on what software we use and how we set up for laser engraving. So this is my quick connect tooling that I've come up with for the Tronxy X3. Just thought I would give this printer a little bit more functionality, and I'm really happy with how they turned out. I'm really happy with how this project turned out, and further along in the video we'll see some clips of all 3 pieces of tooling in action, and I'm really happy with the results. So let's check out some of this tooling in action. and we'll see how we install that back plate. So I have the hot end all disassembled here. I have my new back plate on that only requires one screw connect. And my first step is to disconnect all these wires, cut them all up here somewhere, and put together my quick connect wiring harness coming from the printer. So I ordered a bunch of these connectors, male and female, online. I'll post a link in my description. And I'm not going to use a bed leveling sensor on this, but it is designed to have a spot for the wiring for bed leveling sensor. I'm just going to use everything else. So I only need 4 of these male connectors, and they only go in here one way, and they only go up so far. The only thing you'll need to have to worry about is the spacing in between them. For myself, what I'm going to do is use a zip tie. Grab this here. I've already cut some pieces off it. A zip tie. I'm going to use that as my spacing between my connectors. And once I've gotten them all in place and oriented the way I want so that they match the opposing connector in the tooling, I'm going to hot melt everything together here in the base and the back, and then clean it up, and then I'll have my connector up here that I can just quickly connect to my tooling. So I'm going to go ahead and do this up. Just adjusting my spacers here while I can, and I'm making sure these are out as far as they will go. So let's take a step back and let this set up, give it about 15-20 minutes. That is a lot of hot melt, and then we'll come back to it. Okay, so here's what it looks like now. It's all cleaned up. They're in there pretty good. They're not going to move. Let me get that to focus. If you see here, it's labeled. So we have our heater element, temperature monitoring, our cooling fan, our filament fan, and our probe. So on the tooling that I've designed, they're labeled corresponding to that. So as long as you have everything wired correctly, it should take all the guesswork out of this. You should be able to click it in place and go. So that is a pretty quick overview of how to assemble this piece. And then I'm just going to wire it into the wiring on the printer. Use some heat shrink tubing here and wrap it into the wiring harness so that you'd never know it was there. And then I'll just have this quick connect on the printer. Let me just cut this, pop this in there, and then connect our wiring. And then I'm going to see if my bed is still level. Okay, I have my quick connect tooling installed here with my J-head. The bed's heated up, and we're just going to level the heated bed now. Now that our bed is level, we're going to do a test print with this J-head tooling that we have on here. Let's go in for a close-up. Again, this connector's a prototype, and the final one's going to have a small sleeve that tapers up to support the line a lot better. What I'm going to do here is I put some masking tape down on the outer 2 inches of the bed. And one thing that I forgot to note that I should note is the laser is offset underneath. It's not centered. The laser is not in the center here, so it's offset. And from the corner of my bed here, and my bed is 255 millimeter, the laser is 20 miller offset in this direction. So you got to keep that in mind when you go to do your positioning of your item. It's, well, even if your bed is 220 by 220, the laser is actually going to be 20 millimeter offset from the center here. So keep that in mind. Okay, I bought a bunch of clipboards. So we're going to personalize some of these. So the wife asked me to do up some roses with a skull. So we did that up, and I think now that I have my height fine-tuned in, we're going to engrave this clipboard and personalize it just for her. So let's go to the time lapse and see how this turns out. So here's another incredible laser etching on a clipboard. I purchased a bunch of these at the local dollar store for $1.50 each, just to practice with the X3, and this thing turned out great. I got the centering pretty good on it this time around, and it just turned out fantastic. This was a special request of my brother's, this graphic on here. So now he's got his own personalized clipboard. Just perfect. And I redid my logo on a clipboard. The centering is slightly off, but still, all in all, it was pretty good. I'm really happy with how the laser tooling on the X3 is turning out. Once we have our laser all set up on our printer, we're ready for the next step, and that is to download Inkscape. So you're going to go to their website here. I'll have all the links in my description. You're going to download the latest version of Inkscape, which is 0.92 for your particular operating system. Once you have that downloaded and installed, you're going to go to another website called jtechphotonics.com, and you're going to go software, Inkscape laser plugin. You'll have a walkthrough here on how to set up your image for laser engraving. We'll go through that here in this short video. So, but you're going to want to go to download and overview, and you're going to want to download the latest plugin, which is right here. Once you've downloaded this plugin, it'll come in a zip file. You're going to take the 4 files in that zip file, and you're going to want to put them in this directory right here called plugins, where you see I already have the 4 of them. You're going to want to make sure they're right in there. Once you have the JTech plugin unzipped into your plugins directory, you can now run Inkscape. So this is Inkscape, and the first thing we're going to do is we're going to want to change the format of this blank. So we're going to go to File, Document Properties, and we're going to go down here to Custom Size, and you're going to want to put in your printer bed's dimensions. So on my X3, I happen to have 255 on the X-axis and 285 on my Y-axis. And then you can close this, and now we have our relative print area set up, and our origin point is right here in this bottom corner. So now we're going to want to import a photo, and I have a directory of photos called To Laser Engrave. So we can select something from in here. Please keep in mind that this software does not do shading. It's just engraving only. So let's take, for example, this wolf. We'll just click OK. These settings should all be fine. And we can put it up here right in the center of our print area. Make sure to keep it selected. If you double click here, if you click again, you'll get the option to rotate the image around. Click it again, you can change the size of your image, the scaling. So with the image selected, we're going to go up here to Path, and we're going to trace bitmap so we can get a file that Inkscape can work with. So here we're going to have a bunch of different options on how to trace it. I prefer one of these two here, and this is the threshold for brightness cutoff, and this is the threshold for edge detection. The higher this option for brightness cutoff, the more detailed, the darker the image will be. So you could end up oversaturating the image if this number is too high. The lower the number is for edge detection, the more edges you will pick up. The higher the number, the higher this number is, the less detail you'll have. So we select brightness here, and we just select the default. We click Update. We'll get an image here. And if we don't like that image, we can change this number, and we can do another preview to see what we get. We have more detail there. It's going to vary from image to image, so you're just going to try some numbers here until you get your desired effect. So we're going to go with this one, but I'll just show you here for a quick minute what edge detection looks like. So with brightness cut off, you're going to get your solid image. With edge detection, you can get a nice hollowed out image. So if you want to do this one, you can. If you want to do this one, now if I lower this down, you'll see it'll get more detailed. See, if I go down to nothing, it should be solid. The higher this is, the hollower the image. Okay, so we're going to go with this one for now, because I want it to look similar to the original. Before I click OK, please note the dimensions here. Okay, so we have the smaller dimensions now. That is the newer image. If we click in the background, we'll get the older image. We'll remove the older image out because we do not want that. It is not a trace. We'll delete that now. We can close this window, and here we have our trace. So we're going to select our trace. We're going to go back up to Path, and we're going to go Object to Path, and then we're going to double click our image. So there we have all our tooling pathwork here. Once you've done that, you're going to go up to Extensions. You're going to go down to Generate Laser Gcode. This should appear here if you've put the JTech Photonics plugin in the right directory. Then you're going to go select JTech Photonics Laser Tool. Okay, so M106, that's the G-code for turning on and off the filament cooling fan, and that's where we're going to get our power from for our laser. Then we have our travel speed, which I'll just leave at this. We have our laser speed, so that's the travel speed when the laser is active. You can lower that value if you want a deeper burn, or increase that value if you want a finer burn. And you have your laser power, which maximum is 255. I just picked 200. It worked out for me, but you can play around with these numbers, find the settings that best suit you. And now I'm going to just select my path. And I'm going to just call this wolf. And we'll click apply. It will take a few minutes to generate. The more complicated the image, the longer it will take. This image was pretty simplistic, so it didn't take too long. Now we can close this. You see we have this outline here. That just generated our tooling path using the plugin. So now, the final step we need to do is we need to go to where we created our file. And here is our Gcode for the laser engraving we just did. We're going to need to add some code here up at the top, right around just after the G. Just after G21 here. We're going to add some code. And this is the code we're going to add, and I'll explain why. So this is the code we're going to add. These first two values relocate our origin position. And the reason we want to do that is because the tooling for the laser is offset in that tooling. It's not in the center, so we want to account for that. So the 5mm on the y-axis and the 21mm on the x-axis accounts for the laser's position within the tooling. This line will set our origin point to our new location, and our fourth line will raise our z-axis up to 68mm. This number you can play around with a little bit. I found for the clipboards, for example, this number is ideal for getting the laser to focus precisely to a finer point. You can give or take a few millimeter here for the clipboard. If you want to put a piece of, say, something like 1-inch pine board down, you could add 25mm to this. But this number is a little bit flexible. You can play around with this number to find a number that suits whatever you're doing. You want to take this code, copy it, paste it right here, and then you save this file. And now you're good to go. You can load this up on your micro SD card, put it in the printer, and fire away. There's no wait time for your hot end to heat up or your bed to heat up or anything like that. As soon as you home the printer, which you will have to manually do before you run this program, you will have to manually home your printer. But once you manually home the printer and you select this program, it starts up right away. One other thing I do suggest is practice a little bit. Just take your time, understand how everything's going to line up. It's a little bit frustrating sometimes at first to get your items centered on the bed. What I do suggest is maybe in Inkscape, do a basic, once you have your printer bed outline here, just do a basic image here with maybe 4 corner pieces and a cross here in the center. Put some tape down on the printer, laser engrave the tape, and then you'll have a good idea of your positioning of your bed. So when you want to do a laser engraving on some wood or some acrylic or whatnot, you'll know where to position it to get the best centering of your image. So that's it for my run through of how to set up the software and the Gcode for laser engraving. It's pretty simple, and as I said, all the links will be in the description below the video. One final note: when you're laser engraving, I really strongly recommend you set up some sort of exhaust system. Do not do this in a closed room where you will be in, especially without an exhaust system. I have a exhaust fan in a window on the other side of the room, and I have a vacuum cleaner hose in the back that I clamp. I just use a quick clamp and I clamp it up here just to exhaust the fumes. And so again, I strongly recommend that you have some sort of exhaust system when you're doing laser engraving, and it's in a well-ventilated area. So testing with all three pieces of tooling worked out pretty good. We have the koi fish. It was done with the original hot end in its new tooling housing. We have the miniature Hellboy mask. It was done with the J-head tooling. Turned out pretty good. And we have an example of some of the laser engraving here, which worked out really well with the new laser engraving tooling. One thing I'd like to mention is for the connector for the hot end, I might be changing this around because there is a chance that you can burn this out if you're playing around with it, or if it's not hooked in well enough. So if you're willing to do these modifications, please keep in mind that there is a remote chance that you could burn out this connector here for the hot end, given that it's 40 watts, if it's not seated all the way, or if you take it in and out while the power is on to the hot end. I might actually, if I get time somewhere down the road, come up with a design for at least the hot end. Every other connector on here would be fine, but the hot end I might use this sort of connection. You can go that route yourself right now. You do not have to use this type of setup. You can, when you print the assemblies, the opening here, you could just use this to run your wiring through and connect it how you see fit. You could go this route here, which sustain a much higher current through it than the wiring that's there now. Or you can go a different route altogether. I just went this route for now because it's convenient and it gives it a neat finished look. As I said, I might change the one for the hot end to something a little more durable. So to wrap up the video, let's take one final close-up look at the components, at the tooling. So here's the tooling for the J-head. It consists of 5 printed components. You're going to need your back plate for it. You're going to need 4 screws, M3 I believe I used, I'm not sure, or M3 I believe I used to mount the back plate to the main body. Then you're going to need this locking clip that locks the J-head in place, and another M3 screw there. And then you're going to need another M3 screw for this small mounting bracket here that extends out so you can mount a blower fan. And then for your fans, of course, you'll need a couple of screws for those. I used longer M3s. The slots in the back are so that when the front fan blows air through the heatsink, it has a way to escape out the back. You have mounting points on the side here if you want to mount an auto bed level sensor, and there's multiple so you can adjust your height up and down. The laser tooling is much simpler. It's just one piece. You mount your control board here, and the control board that I purchased, there's 2 mounting holes for that. I'll put a link to this laser that I purchased for this in the description. And there's 2 mounting points for the laser on the back. Power to the laser is supplied by the filament cooling fan. So you're going to want to make sure the line for your filament cooling fan is connected here, and it's spaced out in such a way it should line up with the connector on the incoming that I've used. But make sure you use your filament cooling fan power going to your laser. Currently on the printer right now is the tooling for the MK8 hot end that came with the printer, and it just has it's just a two-piece tooling. It's the main body, and in there you'll have your fan on the side here that cools the heatsink itself. So it's a smaller fan. It's only going to cool the heatsink, blows through in that direction. And in the front you have your blower fan that's going to cool your filament. And on the side of this one as well, we're going to have small holes that you can attach auto bed leveling. I'll leave links in the description to all the items I've purchased that make up the tooling here, as well as links to the software that you'll need to do your laser engraving and whatnot. So let's take one closer look here at the printer. As I said, here we have our holes that we can attach an auto bed leveling sensor. I don't use bed leveling sensors for any of my printers, so we have on the X3 here we have a Y belt tensioning, and this is my design. I've looked at other designs online and some of them just don't print very well. This is very thick walled. It's got a slot in the upper piece here so that the belt isn't interfered with at all, and it's got the much longer handle so it's easier to grab. We have our X-axis bed tensioning. We have no material on the back. We have a slot underneath here all the way up so that the bottom belt's not interfered with, and my hot end can go all the way to this here as well. It's much thicker than the majority of them you'll find online, and again this one has the longer adjustment knob. We have some legs that you'll find on my Thingiverse page, some lion statues, and they give us enough clearance that we can put our electronics box directly under the printer. But really this video is about my quick connect tooling for the X3 printer. Again, in the end I can't be responsible to any issues you have in your wiring. This is up to you how you do that, and if you choose to take this risk, I do recommend for the hot end wiring going with something like this solution here, just because it's higher rated and more durable than these wires here that I have on there. And because if you do take this out while the power is onto your hot end, or if it's not seated if it's not seated properly, you will melt the connector there. For now, I thought I would release these designs onto Thingiverse and just put a caution in there in regards to the wiring. And that just applies to the two hot ends. It doesn't apply to the laser. The laser is fine. It just uses the filament cooling line, and it's not a lot of electricity going through there. That's no issue at all. So I hope you guys enjoyed the video, and I thought I'd give the X3 a little bit of love since I haven't looked at it in a while. I've been too busy looking at other printers. So here you go. It's a big update for the X3. It adds a little bit of versatility to the printer. It allows for quick change tooling and gives you the ability to do laser engraving. Thanks for watching. I hope you enjoyed. Please subscribe.